for joining today's session. My name is Leonie Steenkamp. I head up the marketing department at STBB. And today we are going to be dealing with AI and what AI is. I think that's the hot topic of the press today, where everyone just wants to know exactly what is AI and, is it actually going to replace my attorney and how can it benefit my day? What can we actually do with AI? So this is really a big series that we wanted to do at STBB to share with you exactly what you need to know as an estate agent, and also what you need to know about attorneys and dealing with AI and the pitfalls of it. So I think I wanted to set up a poll, and I'm going to share the first one with you. And we're such a nice big group today, so it's going to be great to get a bit of a feedback from everyone. To actually, give us a bit of feedback on AI. I don't see my polls is not running, but it's not a problem. So I'm going to ask you to post in the chats for me today. The question is, do you think that AI is going to take over the world as we know it within the next 5 years? So yes, no, maybe. No, yes. So we've got a few yeses, we've got a few definitely yeses, and not going to happen, no. So I think actually we've got a good, I don't see, okay, there's one maybe. So I don't see a lot of maybes. So a lot of us are either on this side of the fence or that side of the fence for whatever reason. And that's quite exciting, and next, hope not, next 20 years, maybe. So, we all are a bit all over the show on exactly what AI is and how it is actually going to benefit us. So just before we start and I hand over to Brent, I wanted to just go through a few things on our end. So first of all, there we go. First of all, today's session is going to be about what is AI really? And this is going to be the first part of a 4-part series. The other 3 sessions is going to be one, can I use AI instead of my attorney? And the third one would be regarding estate agents' guide to using AI. So that's going to be specific tools for estate agents to benefit them in their daily lives. And then lastly, it is going to be about the pitfalls and what we need to do as companies and company owners and employees and employers to, make sure that we actually steer our companies in the right direction with AI. So that's going to be the 4-part series. Make sure you join us on them. And then I'm going to introduce to you Brent. So Brent is going to be doing today's session. He is our software developer and operations specialist. He's been in the industry for 34 years. He knows pretty much everything there is to know. So Brent, not to put on you on the spot, but I think you know pretty much everything there is to know. And he's been with this STBB since 2005, and he specializes in specifically systems integration. So that is Brent. And then just before I hand over, just a few house rules. All participants, please remain muted for the session. We're quite a big group. We're sitting at almost 400 people. So if you've got questions, you pop them in the chat for us. We are going to be collating them and dealing with them at the end of the session. And then the presentation slides won't be made available. However, the recording will be made available. So we will be sharing it with you within 24 hours after today's session. So please be on the lookout for that mailer from our side. Then also there won't be any certificates being issued for this session specifically. So you won't be getting that. But however, there will be one issued for the second session where our attorneys themselves will be giving their expert advice regarding AI and the way forward. Then any administrative queries and questions that you have for Brent that we maybe don't get today, you can email them all to marketing1@stbb.co.za, but we'll post them in the chat for you, so you'll have them there and available. We'll be dealing with questions at the end of today's session. And then you can post them in the chat as we go along so that we can deal with them at the end of today's session. So without further ado, I'm going to be handing over to Brent to kick off today's session.
Thank you, Leonie, and welcome everyone to the first lesson in Applied Advanced Mathematics. I hope you've all got your thinking caps on. But no, today will not be an in-depth dive into exactly how AI works. That would take a large amount of time and a lot of understanding, and also a lot of pre-trained ideas. So you need to have certain concepts that you already know before you can start looking at that. But we do hope to educate you on what exactly AI is and kind of how it works on a broader level. So at the end of the session today, you don't have to remember anything, especially when we start talking about terms and acronyms in the IT world. There's always these acronyms that are thrown about to confuse everyone, make things sound more difficult than they really are. Don't worry about those too much. Just try and understand. And I will try to guide you through without confusing you more. But at the end, hopefully, the main goal is that you have a broad understanding of what is AI and kind of how it works. Then when we get to the rest of the things in the next webinars that are following on in the series, we don't have to explain those concepts again. So if you understand what AI is on a broad level, you have a slight understanding of how it works, you're probably better positioned to be able to answer questions like, do you think AI is going to be taking over in the next 5 years? And your answer that you gave to the previous question might change as we get to the end of the session, but I'll give you my view at the end of the session as well. However, we'll really look at that in our later episodes of the webinars. So if I just share my screen quickly, we can take you through this journey of what is AI. And so just an overview, like I said, what is artificial intelligence? So artificial intelligence is essentially perceiving or synthesizing inferred information and demonstrating the ability of a machine to actually present intelligence. So essentially, taking a look at intelligence, what is intelligence? I'll go through it in a moment, but if a machine can, or a program can pretend or at least show to be intelligent, that is deemed to be artificial intelligence. So now that we know what artificial intelligence is, I suppose we could end here. But yeah, no, I will go a bit deeper into that for you. So the other thing is, the big difference, or the big thing to note, is the word artificial. We're going to dive into that a little bit more, but it's pretending to be intelligent at this stage anyway. And we're going to map that word out, because as things go on, we need to change the definition of artificial. So initially, we see computers as trying to be like humans or imitate humans in their intelligence and perform certain tasks. But as things go on, potentially they can actually have true intelligence of their own. And then we need to redefine that term slightly as to what is artificial. So the main thing here is that we have multiple organisms on the planet that we've classed as intelligent long before computers came around. So we've got creatures on the planet that are intelligent. So from doves to mice to ducks, we know that a duck, for instance, once it's born, it can go out into the world, it can forage for food, it can feed itself, it knows how to birth new ducks, it can even count. We've got proof that they can count. There are some seabirds that are actually used by humans in a cruel fashion, where they'll tie a little ring around their neck and only release the neck after they've brought 6 fish back, and the 7th fish they then get to have for themselves. And through doing that, they let the bird fish for them. But that is proof that those particular birds can count at least up to 7, because they know to keep coming back until they get the 7th fish for themselves. But so we know there's intelligence, but we're not really afraid of that intelligence. We've never really been afraid. We've always known that we are, or at least perceived us to be, the main intelligent beings on the planet, and not really afraid of other beings. So knowing that ducks can count, or mice or so forth, we're not really afraid of them. Yet, that's just said, unless we think some weird science experiment has been placed on them, and suddenly they become intelligent, and then they might try to take over the world. But in essence, we're not afraid of the animals and their intelligence, but to some degree, we are afraid of artificial intelligence. And essentially, if we look at intelligence as a whole, humans are afraid of intelligence. So if you have someone around you that is far more intelligent, or at least you perceive them to be so, you might feel slightly threatened by them. If we look at our villains in movies, often it's the crazy mad scientist professor who is very intelligent but has odd little quirks about him that makes him want to take over the world or damage human society or do something like that. So intelligence is seen as a good thing, but also something to be feared. And that's maybe inherently where our fear of AI comes about. But it's important to understand the whole picture before we really take a stance, because we might become fearful of nothing, or we might not be fearful and we should be. So to first understand intelligence, before we can understand what artificial intelligence is. So if we look at Wikipedia, they'll say that intelligence is defined in many ways as capacity for abstraction, logic, understanding, self-awareness, learning, emotional knowledge, reasoning, planning, creativity, critical thinking, problem solving. More generally described as the ability to perceive or infer information and to retain knowledge to be applied towards adaptive behaviors within environment or context. Now, that's quite a mouthful. Oxford Dictionary simply says it's the ability to acquire and apply knowledge and skills. So that essentially, in a nutshell, is intelligence. But if we take a closer look at the pieces that make it up, so in our world, we have lots of things, and those things represent data. So that data would be, for instance, a number 65. That data doesn't have any meaning, so therefore it's just data. As soon as you apply any meaning to it, so we add a label to them, we call it age. Suddenly it has information. Now we call that, it has meaning, so now we call it information. So any data that has meaning is information. If we can assimilate that information and apply it towards anything, that is knowledge. So knowledge is actually, or the application of knowledge would be intelligence. So if you can take data, give it some meaning, apply that meaning to a particular situation, in other words, knowledge, that is seen to be intelligent. We then go further on the human side, and we have wisdom as well, where you are able to then learn from your mistakes and apply previous knowledge from previous circumstances to new circumstances. So in essence, that's what we're going to refer to when we talk about information, well, at least intelligence around information. So is AI a new concept? Well, no, it's been around since 1951 in a working form. So the very first person, Alan Turing, in 1951, created a program that was able to present, or at least show to present some form of intelligence, therefore dubbed as artificial intelligence. Obviously, that program is nowhere near what we have today. And although the people truly refer to him as the god of AI, the more modern people that have come about, like Jeffrey from Google, who now is termed as the godfather of AI. Although Turing, if you ever delve into the world of AI, you'll see the name Turing popping up all over the show. Is the one who started vaulted into mainstream discussions and media and so forth in the last 7 months. It's been quiet. It's been around for ages. We use it all the time and every day. So since the release of the ChatGPT on 30th of November 2022, suddenly everyone's talking about it. But they weren't really talking about before. So every single day we're using AI in our daily life. We are driving cars that may have some self-driving abilities or safety feature that's using AI. When we use Google Maps and we decide we're going to travel from one point to another point, and we need live traffic to tell us how long it's going to take us to get there, we're using AI. So AI has been around a long time. We use it all the time. Every single one of us has actually used AI of some form, probably even today. So just the image that you see, my face is placed over the background images that we have, that uses AI as well to identify me and then take me out of the background and place a different background behind me. These little things and little techniques, but people won't have people start talking about it, and not just talking about it. If we look at TikTok, prior to ChatGPT's release, TikTok was the fastest ever growing application. And it took 6 months to reach 1 million users. And obviously it went on to massive numbers after that. But ChatGPT reached 1 million users in 5 days, so massively faster. And within a month and a bit, January 2023, we're looking at 100 million users, and the numbers just growing after that. So why the sudden uptake? What has really changed? And if you really look at it, nothing's changed on the forefront of the technology, in that it is still producing similar type of things to what we're using. So in 2017, Google released a paper about transformer model, which I'll go through later on today. And that model eventually grew and became, or was used in ChatGPT. And it's been seen now as one of the models that the AI people want to lean on and use going forward until something better is found. But that particular model only came about in 2017. We still didn't hear anything of it. Google's actually used it. When we use Google searches, that's already applied there. So there are things like BERT. If you use Google, it uses BERT for its, in the background, BERT for its AI. So if you're typing text and you're typing mistakes, and it's doing some predictive analysis. So when you start typing the one word, it's already prompting you for the next word that might follow. All those little things, it's using AI in the background just to predict what it is you're trying to look for, and to help you find the correct information. So we've been using it all along. Nothing's really new. No one's freaking out or saying anything about it. ChatGPT releases, and suddenly there's a major uptick in action and reaction. And the main thing that's changed, the one thing that's different, is that the AI now seems to be responding as if it is human. So before, all the different AI we interact with, I need to have a Google Map navigation. I say, I'm at this point, I want to go that point. It gives me live traffic and it tells me exactly how to get there. I'm not worried about that. That's just a great little tool. It doesn't in any way impact on my life, because I can't do those things. I can't do what that AI is doing. So it's not in any way going to take anything away from me in my life. It's only going to add to me as a tool. So if I have a tool that's replicating me and what I can do, I might become a bit more panicked. So with all these other tools, it just looked like it's a tool.
Or really mental chewing gum.
All right, so it's not really the AI per se, but just seeing it as a tool, something that can perform a function for us. But now with the GPT coming along, you type something in and it responds back like a human. You ask it to do something and it performs that task and gives you something as a human would do. So you ask it to write a poem, you ask it to write a story, you ask it for a business strategy, and it replies back not just with the key points, but as a human would reply back. And that's the key thing that's changed. So behind the scenes, some of the technology has changed. In the old days, Turing's days, they had plain computers that would work. Those computers would have to have some code written. The code gives the computer an instruction. It follows the instruction and it has a result. So that's how standard computer programs work. That's how we work with them all day still. They're not going away. You have some form of input, normally a user typing something or something visual. It performs a function based on a preset of actions that it has programmed into it. And with that, you get a result. And those computer programs and the computers that they ran on obviously are getting better and better over time. But humans don't like to spend money on things unless they're going to make money back. So with scientific research, we'll apply money into a field until we have a theoretical understanding of it, and then we seem to stop spending money. But with the technology side, we had something called Bitcoin, which was making a nice big fuss in the market. And with that, there was a race to get faster computing power, and people using graphics processing devices, GPUs they call them, to do faster processing of information so that they can outpace the rest, so they can mine Bitcoin and make money on Bitcoin. Now that's a good thing, because in the end, they're able to make money, so they spend more money on technology, and the GPUs get faster and stronger and better, and they use those same GPU type computers for AI. So in the long run, AI just gets better and better as well. So with the 2017 paper released by Google on the transformer model and the GPU increasing, the ability for the software to present itself in the AR world increased with speed, and the clever techniques for representing the data, but it's still pretty much the same type of AI going on in the background. So what does AI really do? It takes an input, it applies some cognitive processing to it that is normally mathematical. Those are normally called algorithms. So an algorithm is either some piece of maths or it's a set of instructions. It applies that to the data and then it has an output. And that little piece in the middle where it applies the data is normally hidden from the input and the output. So they don't see each other and speak to each other. But what happens with AI is they'll create a neural network. So like the brain, when they want to make a computer perform like a human, they will analyze humans and then try and replicate what they see. The problem we have with that picture is that humans don't really truly understand our own brain and the way we think and understand. So we can only observe input and we can observe the output. We don't really know what happens in the middle. We make some assumptions about that. And then because we don't know how to replicate that, we use maths and other methods to try and perform a similar type of output that we're getting from our brain. So if we observe a child, for instance, playing with a puzzle, trying to put a puzzle piece into the space where it must go, or if it's just a round circle, trying to place that into a square hole, and they push it around, they can't get it in, they move to the next hole, they eventually get it in, they remember that it went in there, and they take the next object, and after a while, through memory and repeat, they are putting the right object into the right hole. So they try, the early adopting AI technology tried to replicate that, and then as studies increased, they try to really understand, well, what is actually happening that makes you remember these things? And they try to replicate that in a mathematical fashion. But unfortunately, it's not the same thing. So we don't really understand what makes the human intellect tick, nor other organ-based creatures like ducks and mice and so forth. But we try to replicate in a mathematical fashion. That, however, means that if we replicate that in a good way, we can potentially outperform our own brains. So when analyzing the different techniques that we may be using in our own head to perform intellectual feats, we may say, map it out in a mathematical way. We may then say, hang on, I see a problem with that mathematical way. We can improve it by changing the mathematics slightly so we have a better outcome. And then from that, we get our current AI, which is just improving. But the main thing there being, like I said, that it's appearing to be human. And I use the word appearing, because as we go through now, later on, I'll show you exactly how it works on an overview level. And you'll see that it's actually not human, at least yet. So if we look at the different types of AI, and this is the traditional ways of classing AI, you would have 4 types, really. You'd have reactive. So those have no memory at all. They respond to different stimuli. So way back when there was the IBM Deep Blue computer that beat Kasparov at chess, the chess champion at the time, that was a reactive type of AI. So no memory at all. Then you get limited memory. So these use memory to learn and improve on its responses. So it takes the previous reactive type of AI, but it gives it some form of memory, so it can remember where it's gone wrong, apply some changes, get to solutions faster, etc. That's actually where we are at the moment in the AI space. We're still under limited memory. And then the next step on is the theory of mind. So this is where they start to understand the needs of other intelligent entities. So they'll understand the needs of humans, understand the needs of those ducks, understand the needs of other AI. That's classed as theory of mind. And then you get self-aware. So those present human-like intelligence and self-awareness. So it's obviously multifaceted, in-depth intelligence, but it's aware of itself. And just with that one, bouncing around on some places, if you go and watch videos, you would find some evidence that AI is self-aware. So you'd have little robotic arms that can move around a space to do things like either pick up a ball or touch an object. And the main purpose of that AI is things like manufacture. So it could be a welding arm that needs to weld joints on a car during the manufacturing process of a car. And it needs to know exactly where it needs to be for the welding on that spot joint, but just not just in a preset, perfectly defined space like they currently have, where you can program it to move the arm to the exact point and perform the weld. If something happens in that space, so for instance, a human is standing in where they shouldn't be standing, or something is shifted and moved, the current programming can't handle that. It needs to have precision. So with AI, the AI can detect what's changed and make its own changes and enhancements to move to where it actually needs to be. But it can then avoid any obstacles that it has in its path. So to do this, it needs to understand the space that it takes up. So it needs some spatial awareness. So it maps itself on all the different positions it can occupy in a given 3D space. It then can map any object in the 3D space that object can take up, and it can make sure that it avoids that object and doesn't clash. So in doing so, it has to be aware of the space it occupies. But that isn't actually self-awareness. That is just aware of the space that it occupies when it's busy performing its task. True self-awareness is the understanding of who you are, where you fit in, why you fit in, those type of things, which even humans still actually struggle with slightly. But in essence, we are not at self-awareness. We're far from that at this point in time. But with the changes and the rate of change with AI in the last while, there are some people who feel we could be at that point potentially even within this year. But I'll leave you to make your own call on that for today, and we'll chat a bit more about that side of it in our last session on the series. So when we're talking in the tech industry, in the IT side of things, and these are some of the terms you'll hear them throwing about, the classification is a little bit different. They only have 3 categories where they classify AI. So the first is narrow intelligence, artificial narrow intelligence, or ANI. So these perform tasks autonomously, but it's specific tasks. And that's kind of where we are at the moment in AI. We are at the ANI point in the space. Each AI, no matter how fantastic it is, can only perform a task around a specific requirement or need. So when we unpack the AI models in a moment, we talk about things like neural networks and the neural nodes and things like that. Essentially, it's large computer models that have captured huge sets of data to apply certain functions or respond to things in a certain way, but it's all targeted at a fixed type of response. So even with ChatGPT, you'll see the makers of ChatGPT called OpenAI. They have 3 products. They have DALL-E, which is an image-based product. They have Whisper, which is a voice recognition software. And then they have the chat side of it, which is ChatGPT. But behind the scenes, all those products use the same type of AI to perform. So they are all narrow intelligence. They're specifically targeting a single type of task. And if you think about humans, we do more than just one thing. So speaking to you today, you listening to me, those are already 2 things. You can listen, you can speak. So we can group that together into a particular task. But then if I need to get up and walk out of the room, that will be a separate task. If I have to then work with an object like a computer and actually type on a keyboard, that will be a separate task. So every single thing that you do is a separate task. And if you analyze a human, there are billions, millions, or trillions of different tasks that standard humans capable of doing and performing. So if you move across to the general intelligence, artificial general intelligence, that's when the AI is able to learn, perceive, and understand and function completely like a human. So it's multifaceted, multiple tasks that it can achieve on its own without any input or change once it's learned its behavior. So basically becoming a replica human. That will be AGI, or artificial general intelligence. The next step after that is artificial superintelligence. So that's where the computers exceed us. They start having far deeper, multifaceted intellectual discussions and decisions and computations and things that we can't even comprehend. At that point, when that happens, when machines and in the market, they don't talk about if, they talk about when, but in my mind, it still is an if. But at that point, it becomes what they call the singularity. So what is the singularity? Well, that is essentially where the computers outthink us. They can perform on their own. They can do everything like a human. That was the AGI, but now they are better than us. We can't understand the stuff they're doing. We can't comprehend what they're going to be doing with the stuff they understand and how they will react with the things that they can do and understand. We hope, obviously, that it all works in our favor and there's a great world where AI just does everything for us and helps us along. But where we are currently in the space is the narrow intelligence. And in that space, and just the knowledge that AI has been around for a long time, one of the first things people always think about it is it going to replace me? So we'll look at that a little bit more later, but for now, just think that AI has been around for quite some time. It hasn't replaced many people, but it's actually created a lot of jobs along the way. So it's created far more jobs than what's replaced. But we are in the narrow space. And if it turns over to the general intelligence space, that's a slightly different story. It can then act as if it is a human, and then potentially we don't really need the humans to perform the tasks. But humans can still compete with AGI. It's only once it becomes the ASI or super intelligence that it then outperforms us in every single way, and we can't even understand the things it's thinking of. And when we talk about general intelligence, we also talk about emotions. So emotions are very important when it comes to intelligence. Sometimes they get in the way of intelligence. Then if you look at the intelligence of emotions often get in the way of simple tasks. But sometimes emotions are required to perform tasks. So think of a simple thing like a pinball table. If you're playing pinball on a pinball table, the only actions you've got are the two paddles that you can flick up and down. And you have some additional rules. And one of the rules is don't damage the pinball table. It doesn't belong to you, etc. But as you're playing along, one of the balls gets stuck and you can flick the pedals and nothing happens. Now, if a machine was in that position, it could keep flicking the pedals, but it couldn't move on any further. But humans have additional emotions. They get slightly frustrated and angered. They feel done in because they've spent the money to play the game, but the ball is stuck. So their emotions let them override the rule, which says don't damage the machine, and they then bump the machine and the ball dislodges and they can carry on playing. So without the emotion in that particular task, they wouldn't have been able to overcome the obstacle that they faced. So emotions become critical, especially when you start dealing with other entities and have to consider their feelings and the way they interact with each other. So the emotional side is actually being investigated. There's a lot of studies around, obviously from a psychological point of view, we've been studying emotions for a long, long time, but there is a field in AI which is actually looking at artificial emotional intelligence as well. It's really early on, but they are looking into that. So artificial intelligence, there's a number of subsets, and of these subsets, some of them get confused with each other and used as the same thing. So we've got AI and we've got machine learning, and they essentially are all part of the same thing. They're subsets of the same bigger picture, but they aren't the same thing. So artificial intelligence is a techniques where computers are able to mimic human intelligence and logic using rules, decision trees, machine learning, etc. So AI as a whole, and everything we've spoken about as AI together, it can incorporate, doesn't always, but it can incorporate machine learning. So the fundamental type of AI where it doesn't have any memory, it just performs an action that doesn't have any machine learning. But as soon as you let the machine learn slightly, it can remember certain things. That is machine learning. So machine learning is part of artificial intelligence, but it isn't the same thing. It is a subset of it. But that machine learning includes statistical techniques that enable improvement at tasks with experience. So it can repeat certain tasks, it can see how it performed, it can compare, analyze, and then reperform the task and perform it better, or perform it worse and learn from the mistakes. So that's machine learning. And then you also hear another term being bounced around called deep learning. So deep learning and machine learning are similar in that deep learning is a subset of machine learning. So you have artificial intelligence, part of that can contain machine learning. Machine learning can contain deep learning. So deep learning is basically similar to machine learning, except that the algorithms permit the software to train itself to perform the tasks. And we're talking about multiple layers and vast amounts of data. So with the AI and the algorithms, an algorithm, like we said, is a set of mathematical rules or a set of instructions that it follows. And with deep learning, there's multi layers, and each layer has multiple little algorithms that interact and speak to each other and perform certain tasks. And all those tasks together, linked with all the different layers in what they call a neural network, forms the deep learning. So it analyzes the data from many different aspects and points, and it has many different functions working on that same data. So that is machine learning with deep learning. And then you also have things like robotics, where it's actual physical machines that move around. Everything that does not include robotics is that in the AI space is just software. So the software can have other things attached to it, like a camera. It can have image for input. It can have sensors for input. So it can be machines in a workspace that have a heat sensor or a moisture sensor and so forth that provide input. So that it will be artificial intelligence applied, but it's not robotics. The robotics is when the machine actually moves for itself or by itself. And then you have neural networks. So the neural network is basically a collaboration or connection of multiple neurons, much like our brain has got. But each neuron is a little piece of computer code that has some mathematical equations in it, and it has some instructions built into it. Those algorithms that we spoke about, that makes up one node or a neural link. That can work with some data, it can interpret the data, it can perform some statistical checks and balances on that data, and then it passes its findings on to the next node. The next node does something else with that data, and so it keeps moving it on down the chain through multiple layers and multiple different algorithms along the way, and eventually it can analyze the data and remember what it has analyzed about that data. So most of our AI that we have performing massive tasks like ChatGPT have neural networks behind them. And the neural networks have obviously had some deep learning. So it has some memory, it has a lot of data that's moved through to analyze and then act on. And then you've got NLM, which is a natural language model. That's just a way to look at the way AI can speak in a natural fashion. Obviously, ChatGPT has got that built into it as well. So when we look at what they talk about in the different algorithm types, I'm not going to go into this in depth, just so that you know that there are a number of these things out there, and don't get confused with the other terms. They basically just perform similar stuff on the data in a different mathematical technique. So you've got convolution neural networks, you've got long-term, short-term memory networks, you've got recurrent networks. Recurrent networks often will include a long-term, short-term network within it. So they can actually have multiple layers, and each layer can have a different type of algorithm being applied. And then so the list goes on, and right at the end, you've got transformers. Now, ChatGPT is a transformer neural network, and we'll look at that one a little bit more. That's the more modern or more later released one that everyone's got a lot of hype around and feels that that one has some of the best potential. But things like convolution and neural networks have been in place for a long time. They are used for things like self-driving cars, image recognition, AI around security camera footage, and so forth. So ChatGPT itself, we're going to use this as an example because if you look at the previous slide, there's a lot you can go through, try and unpack the way all the different types of AI work. But we're going to look at just one of those types, which is called transformer networks or transformer models. So ChatGPT is the GPT part about chat. We all know what that means. The GPT part means generative pre-trained transformer. So generative, yes, it generates output. Pre-trained, yes, it's been trained on some set of data. And transformer means it is a transformer model of AI. So it takes the AI model to apply to the data based on the transformer model. I will look at that in a moment and give you an example of how it works. So currently it's at ChatGPT 4. 3.5 was the one being used when everything got exciting and all hyped up. GPT-4 has more, it can handle more data, larger segments of text. They still can't actually write novels and things like that. The amount of text they can generate is still limited, but it's growing with each iteration of GPT. It is more regulated. So it has more rules in it saying it can't respond with hate speech and so forth. It has less hallucinations. So when it makes a mistake and it gives you fake data that's made up, they don't call that a mistake or an error or a fake data. They call that a hallucination. It hallucinated the fact that it's giving you. Right, and then GPT 3.5 was trained on 570 gigabytes of data, the subset of which it stores its neural network in around 45 gigs of data, and it has 175 billion parameters. And with GPT-4, you're looking at, they say, around 1 trillion or even 100 trillion parameters. So what are parameters? Well, when the data looks at a particular item that comes in, the set of mathematical rules will analyze that data and it will come up with a prediction. And that prediction is written down as a score, a prediction score. And it only remembers those prediction scores. It doesn't remember all the data. So when something new comes in, now it's been trained, it remembers all these scores that it's using to predict with. When new data comes in, it applies those rules. All those little rules that it's built up on its own, all the little statistic analysis results that it's built up, those are the parameters. So the parameters are all the little rules that it's created around dealing with the data. So the more it has of those, the faster and the better and the smarter and the more accurate it becomes. So from 175 billion parameters for GPT 3.5 to a trillion or 100 trillion on GPT-4 is a massive jump. So GPT-4 can also handle images as input. There's a famous thing where someone has given it a photograph of their fridge. It obviously has identified the items in the fridge from the photograph, and it then gives them a recipe of what to make for dinner that night. So that's quite a handy tool, and the hype on what these things can do potentially is obviously just increasing by the minute. But other than parameters, you will hear another term called hyperparameters. So hyperparameters are the rules that the humans who built the AI place upon the AI. So it has these hyperparameters that tell it when you learn, you can only go through the data so many times. It must discount data that reflects certain things. So remember that AI is trained, especially this GPT, it's pre-trained on sets of data. So it can only spit out whatever you've trained it on. If we trained it only on Shakespearean writings and essays and novels and plays, it can only ever respond as if it was Shakespearean and respond with the context of a Shakespearean novel. If we only ever trained it using hate speech, it would only ever be able to report back on hate speech. So the key thing there is, what does it get trained on? And they don't really tell us that. They don't really tell us what data. They just tell us it's a large subset of data across multiple different avenues. And even things like the legal fraternities, the GPT-4 is able to actually get a close on 90% score for a general bar exam in America, which is fantastic if all you ever had to do is pass an exam. There's more to operating that field than doing that, but we'll speak about that later on. So how does a transformer work? Well, essentially, it takes an input, it has a prediction about the likelihood of the output, and based on the prediction scores that it's had in its library that it's looked through, it gives the best score that it can find with that. So if I just say to everyone present today, the cat sat on the, and I wait for another answer, most people are probably going to say mat. Some will say table, chair, car, whatever the case is, but the majority of people will say mat. So statistically, if I look at all the answers from everyone and how to collate that into a system that looks at the answers and looks at statistically what is more likely to be the answer, well, as soon as I say the cat sat on the, it'll reply with a mat. If the people in the audience all decide that they are saying sat on the roof, and it reanalyzed the data, and it sees that roof is a higher probability answer based on the data it's now looked at. The next time it answers, it will answer the cat sat on the roof. So it'll look at the relationship between the words in those sentences, and through that give you an answer. So essentially, and not in depth detail, there's a lot more to it. And there's a lot of mathematics that goes on doing the algorithms. They even have additional components about finding the position of text in a string of text or sentence, which uses cosine and sine functions just to tell it where it is in that sentence. But essentially, if I have something that says, "Hi, how are you?" on a broad level, it would then respond with, "I am fine," and there'll be an end instruction that just tells the system it is finished responding. So before I go into the in-depth part of it, into the overview of this, just note that these AI tools sit on their own and still have to interact with us in some way. They still need input, and they still need to provide output. And that input and output is still standard regular programs at this stage that people are writing and coding around the AI to take our input through maybe a website or some other fashion, pass it into the AI transformer, in this case, ChatGPT. It analyzes it and it gives back output. That output then is presented to us in some fashion, like a website screen somewhere. So the AI doesn't do all of it. It just does the heavy lifting of analyzing that data. So if I take the "Hi, how are you?", what it does is it looks for key words in that input sentence. It rates them mathematically by sequence to see which one is statistically the most important. And it's looked at all the thousands of millions of iterations of text that's received over time. And it compares the words against each other to see which ones are most prominent in a sentence structure. And in English language sentence structure, the simple one there is, once it's started, the simple one is "you." So it goes, okay, the actual target of this sentence, the statistically highest probability for target is the word "you." It then looks through its probabilities to see which is the matching word for that, and that would be "I." So it returns "I." And then after it's done that, statistically, the next prevalent word would be "how." And then it needs to look at all the possible answers. So there could be millions and millions of potential answers. It doesn't look at every single one of them. It will give statistically the most likely. So in this case, it could say "fine." And then it's based on those two, the "I" and the "fine," it will then look at statistically all other sentence structures to see statistically what is the more prevalent way of linking "I" and "fine," given that it came from "how" and "you," and then it completes the "hi, how are you" with a "I am fine." And you can test this by going to ChatGPT and you can type in "how are you." It'll give you an answer. It won't actually say "I am fine" because it's got a lot more learned text. So it'll give you a much bigger string of text. But instead of saying "how are you," you can actually just say "how you." "How you" will return the exact same answer as "how are you?" or "hi, how are you?" It looks at the prominent features in that text, and it returns the answer based on relationships between the data that it's analyzed. So that's overview how the transformer decodes the data. But in essence, it's obviously doing a lot more. There's a lot more data that it's gone through, and it remembers the relationships, but it has these hyperparameters as well that try to make it more human. So those hyperparameters are the things the humans have told it how it must respond. So the humans have told it, don't always respond with the highest ranked item. So if the highest ranked item is "fine," don't always respond with "fine." You can respond with "fine," let's say 60% of the time, but the rest of the time you must use one of the other words. So it'll say "I'm okay," or something like that. "I'm doing all right." And that way around, it starts to make it seem more human because you're letting it build in some form of error. So that error being, it doesn't always give the highest ranked word that's linked to the "how." In this case, "fine" was the highest ranked. It can give a slightly lower ranked word. And then with the data that it analyzes, tells us how it's going to actually spit things out. So if you train it, like I said, on only hate speech is all you'll get out. But if I train it on all the novels that have ever been written, if I train it on all poems that have ever been written, if I train it on all the scientific white papers that have ever been written, especially around language and linguistics and how different languages work and how the languages interact with each other, it can start doing things like not just making up poems, because it starts off with something, you give it as a prompt and it fills in the blanks based on those different relationships, but it can also do things like answer questions that are about complex things, like your calendar. If it can look at your calendar and a program looks at your calendar and says, you are supposed to go have an appointment at this time, I have an appointment at a different time, and someone else's appointment at a different time, and we ask for it to schedule an appointment that matches all of us. They can take all those inputs in. It can work out which is the best time based on the relationships of those different times, and it can answer us back. So it's not actually working anything out. It's looking at each input that's coming in and how that input has a relation to the other stuff it's learned, and it will give the most probable related item back as output. And obviously there's these little neural nodes that each one is looking at a separate piece, and that they run in conjunction as something called multi-headed. And the multi-headed part of the model is multi-headed self-attention model, but the multi-headed part means that it's running multiple little queries on the data you're putting in at the same time. So it can come back with the answers much quicker, but also when it learns, it can learn a lot quicker too. So it goes through the set of data that's got all those novels, all those different things, and they can return all of these answers quite quickly. But if we then think of it, that what happens if we then train it on only those texts, it can only then repeat what we already know. So it can't make up new things. It doesn't start off with its own query. You have to prompt it and send it an input. It then takes that input, it analyzes it, it finds the most likely output, and it gives you the most likely output back. So it's not thinking, it's not generating things on its own, it's not actually coming up with text and poetry and stuff on its own. It's taking your input and it's using all of the stuff it's learned and the relations between that to find the best, and then based on its rules, more human output that it can find. And that's what it gives you back. But it's not plagiarism. It's just a copy or collection of everything it's learned, like we humans do as well. And it can be unique every single time based on someone else asking that question. But in essence, that's what it's doing. It's taking an input, it's statistically applying a value or a weight to that input, and then finding the resultant match and returning that resultant match. But if we train it on everything, so if we train it on all the Twitter feeds that have ever been, all the WhatsApp chats that have ever been, all the content from YouTube videos, how-to videos, and all these different things, those relationships between the input and the output becomes quite massive. And it basically at that point can return everything that a normal human is able to return, because humans learn in a similar way. We give humans information, they store it, they aggregate it, and at some point they can spit it out. They can apply it to new tasks that have never performed before. This is what AI does as well. It takes the learned information, and through statistical weighted averages, it can apply it to tasks that it's never seen before and come up with a fairly good answer. So that's essentially how transformers work. Because we're running out of time a bit, so I'm going to skip through the last bit. But some interesting talking points, and we'll go through these next few items more in the sessions that are to come. But there's the whole talk about Jeffrey Hinton, who quit Google. There's a couple of things to remember about these things. Yes, he's like 75 years old, so he was probably going to retire anyway. So just the fact that he's quit Google doesn't mean there's a major upset in the world, but he does want to continue working, but more around applying some form of regulation around the industry. And also in March this year, ChatGPT had a data leak. So that data leak leaked out information about people who are paying for GPT and their banking details, as well as some information about the people and the queries they're putting in and responses they're getting back. So that's something else that obviously the market became quite concerned about. Why is this leaking my data, and what all can happen when these things start going wild and leaking things all over the show, and security risks and so forth and so on. And a number of the big players in the market not just led by Jeffrey Hinton, but a number of the players in the market all signed an agreement. Well, they've started signing an agreement that they're going to start working together on shaping and shifting the rules and regulations about how we use AI, what information we feed it, versus what it can come out with, just in case it can grow to become something that takes over the world. And there are some videos out there where they're speaking about it potentially at the rate of growth could get to the point of the singularity by the end of this year. But that's all up to debate. If you look at what it's really doing behind the scenes of taking input, analyzing it statistically, finding the best statistical match and giving you an output, in my mind, it's not really thinking, it's just pretending to think at this point. But that's my opinion at this stage. There'll be other stuff we'll speak about later on. So is the human race doomed? Potentially. What I can guarantee you is that you won't be doomed before our last session in this webinar series, and we'll unpack that a bit more in that session, looking at what are the pitfalls and what we have to worry about, what we can be happy about and excited about. We'll look at that in that session. Thank you for your time. I hope I haven't confused you more. I hope I've given you some food for thought, and we'll unpack this a lot more in our future webinars in the series.
Thank you so much, Brent, for today's session. I hope everyone found it very informative. I think we had quite a big in-depth look at AI. Well, to us, it was in-depth, Brent, even though you feel it was just an overview. But it was very knowledgeable. I think we all have a better understanding, actually, of what AI is. There were quite a few questions. Just the questions regarding the attorneys, POPI Act, etc. Those we will be dealing with in our second session on Thursday, where we will be getting our attorneys and experts to ask the questions regarding whether AI can actually be used instead of our attorneys, and how does that work in the legal world. So the other questions that were posted as well was from Estelle specifically, Brent, and she had just a question regarding AI and whether it is a system program that will be able to be downloaded, and whether there will be securities attached to it, and whether you would be able to communicate with someone who doesn't have AI. So seeing it as a type of system that you actually probably download or something to
yes,
that extent.
To look at that, the AI itself, obviously there will be tools that interact with the AI models, but the AI models require massive computing power. So they have GPUs that they run on. There's levels in the neural networks, a lot of computing going on. So it's not going to be running on your phone or your computer on your side. It's generally going to be running where you connect via the internet to it, and it returns values back to you. Especially if you're looking at, do you need to have it to communicate with other people? No. Obviously, there'll be programs written around these things to curtail them in the way they work with us and interact with us. Some of which, for instance, if you have AI looking at your email system to protect you so your staff don't accidentally send the wrong information to one of your clients instead of a coworker, those tools exist, but they look up, they take the data, they analyze it using all the methods, and once they've learned it, they keep the small learned part of it locally, and they interact using that. So some of it can move across to local machines, but in general, you interact with them on the large GPUs in the internet that are connected via that method. I hope that answers your question.
And we would look forward then to also seeing you on Thursday, like I said, where we will be dealing with exactly how AI is going to affect the legal world and what our experts have to say. Thank you, Brent, for your time. And that's it for us. Thank you.
Thank you all. We'll be looking at more in depth later on as well.